Position. All right, so we're talking about position, where something is, stands. We're interested in cases where position changes, right? And it changes with time. So we can have different depictions of that change, right? We can have motion diagrams, we can have tables, we can have graphs, and we can have equations. Just to start, let's talk about a change happening in a table. So let's say that something is moving, and when we start observing at time 0, it is 2 meters away from the origin. And then after another second, I see this object being at 5 meters away from the origin. And then in another second, let's say that is at 8 meters away from the origin. If I do it as a motion diagram, I should say, okay, where is my origin? Here. And then 1, 2, 3, 4, 5, not enough, 6, 7, 8. So my object starts from 2 meters, it's always a point. And then after 1 second, it has gone to 5 meters. And then after another second, it has gone to 8 meters from the origin. All right, this is how the motion diagram should look. This is the graph, and if I want to present it as a graph, I should have the values of time here. The time is 2 seconds, so 0 time starting from here, 1, 2, well, my position changes up to 8, so I should have 1, 2, 3, 4, 5, 6, 7, I need some more, 8. So at time 0, my position is at 2 meters, and then after 1 second, it has gone to 5, and then after another second, it has gone to 8. And of course, in between, it has moved to all the in-between positions. So it should be something like up, straighter, like that. Okay, you know what I mean. So this is how the graph would look. It should be a straight line. It doesn't look like a straight line, right? And I have to make it a straight line. Didn't go through. Losing time. If I want to write an equation, it's so easy, because you already know that from algebra that when you have a line graph, the formula is, I hope you see it, y equals mx plus b, where y is the quantity on this axis, x is the quantity on this axis, m is the slope, and b is the y-intercept. So right now, on the y-axis, I have the physical quantity of position. And on this axis, I have the physical quantity called time. And the y-intercept, too, is actually my initial position. Okay? For initial position, I will have the symbol of position with a 0 as a subscript. Now, what is the slope? Rise over run. So the rise, which is the delta x, the displacement, is final minus initial, 8 minus 5, it is 3 meters. While the run is the time interval, delta t, which is 2 minus 1, just 1 second. And And from this I can see that the slope, can find the slope to be, let's write it here. Now let's write it here. The slope is rise over run equals 3 meters per second, 3 meters per second. Okay? Now, we said the slope is such a nice quantity. It shows us how it changes. We can see if it changes in a constant way or not by checking the slope in every second. I can find if it changes in the same rate or not. Oh, that's such a nice quantity. Let's use it. Let's give a name. So, what is the Greek name for arrow? It's velos. So we decided to have it as velocity. So we said the slope in a position time graph will be the velocity, and it will show us how position changes with time. Now, I gave a simple example, and I hope to give some more examples in the next video. If I find a way to stop it.